Hey beautiful guys, welcome back to yet another episode of Being Physicist. In this video we're going to be talking about the discovery of antimatter. So it was all started in 1928 when a British physicist Paul Dirac wrote down an equation that combined quantum theory and Einstein's special theory of relativity to know the behavior of electron moving at the relativistic speed. This equation won Dirac the Nobel Prize in Physics in 1932. So what Dirac did was he combined the Schrodinger equation and Einstein mass energy equation, and after combining he came up with this special equation, which is actually very famous equation, and it is known as Tarak equation, as you guys can see on your screen right now. So the interesting thing that happened to this equation was it has got two solutions, one for the electron with a positive energy and one for the electron with a negative energy, same like this equation. But for the classical physics there is no room for the negative energy, which means that energy will always be a positive number. So it was a very crucial time for him because his equation was returning two solutions. So the second solution was not worth considering because it was against the laws of physics. So instead of ignoring his second solution, he interpreted the equation to mean that for every particle there exists an antiparticle which is opposite in charge to the particle. For example, for electron there would be an antielectron or a positron which has the same mass as electron has but with a positive charge. So it was his prediction about the positron. So now let's get to know that how actually positron got discovered. So in 1932 Carl Anderson discovered positron while measuring the cosmic rays in Wilson chamber experiment. Here you can see the picture of cosmic radiation from 1932 showing for the first time the existence of anti-electron. The particle enters from the bottom, strikes the lead plate in the middle and loses energy, and can be seen from the greater curvature of the upper part of the track. So because Dirac equation came true, so he was awarded with the Nobel Prize in 1932. So now let's talk about the discovery of antiproton. So in 1954 at Lawrence Berkeley National Laboratory, the bavatron that produced antiproton was switched on for the first time. That particle accelerator was capable of producing energy up to 6 billion electron volt. The energy range for the bavatron was not chosen arbitrarily, but specifically picked that gave the necessary environment for the production of particles as massive as proton but with a negative charge. When this experiment was started, there was anticipation everywhere in the families of physicists. Every physicist was curious to see the production of antiproton, even though some physicists started to do bets on whether the antiproton would be produced or not, because at that time physicists didn't believe that the bavatron is the one that could potentially produce antiproton, and many of them were very hopeful too. So Emilio Segre led this experiment. So the team of this experiment was divided into two parts. Researchers Owen Chamberlain and Clyde Wiegand were in one group. Their job was to identify the particles as antiproton by determining the mass and charge of the particle produced by slamming protons into a fixed target. The second group was led by Gerson Goldhaber and Eduardo Emaldi. They were supposed to record the collisions on the photographic emulsions and look for the star-shaped energy burst expected from proton-antiproton annihilation. So Wiegand placed a blackboard at the bavatron entrance and posted the daily updates on the group progress. Here you can see the picture of the blackboard, which was of October 6, 1955 at 4:30 p.m. It shows that the group finally detected 38 antiprotons. This picture shows that only 38 antiproton were able to make it to the surface from the pool of nearly 2 million particle events. So now we have produced an antiproton too. So now let's talk about the production of antihydrogen atom. So in 1955 at CERN, Switzerland, finally scientists synthesized an antihydrogen atom for the first time. So that was the whole journey of discovery of antimatter. So in our next video, we will talk about that why don't we see the antimatter around us. So stay tuned to the channel. Thanks for watching.